is coming in. It's a massively emerging field. So it already exists. So aside from the established markets, we've got 3 emerging markets. We've got synthetic fuels. So that could be synthetic kerosene, synthetic diesel. We've got building materials, and we've got plastics. So on the fuel side, the massive opportunity for using captured carbon to create synthetic fuels is it will finally uncouple transportation from fossil fuels. So one of the biggest challenges around moving away from oil and gas is how are we going to continue to move from place A to place B? Jet fuel is very, very difficult to replace. Electric planes, yes, there are some applications for sort of short island hops, but it's going to be very, very difficult to get battery technology to a point where you can fly from London to New York. So drop-in synthetic fuels are looking more and more like the answer. And synthetic fuels are made using carbon dioxide and renewable energy and water. There are other kinds which are sort of biological origin, but that, and David will talk a little bit about this, potentially competing for food crops. So the big opportunity that I'm seeing with the synthetic fuels is you'll be able to continue to maintain a transportation system that doesn't rely on fossil fuels to such a large extent and doesn't compete with food resources. Today, this technology is expensive. It's not well proven, but Bloomberg NEF, so Bloomberg's sort of energy and sustainability research arm, predict that by 2030 there will be 1.1 billion gallons of e-fuel capacity around the world, and that will only go on to grow. And then building materials is slightly less established, the technologies behind it. Today you can, if you go to B&Q and you're buying concrete, cement to do a sort of home DIY project, you can actually buy some that's got a biochar mix. So biochar is kind of plant matter, and it can be that's been burnt potentially in a biomass CHP or potentially a byproduct of an ADR, and it can be added to concrete and asphalt today. But the technology to fix captured carbon into concrete is very emerging. I read only yesterday in the Chemical Engineer, which is the Institute of Chemical Engineers magazine, that a German company had just begun fixing CO2 in concrete. So the technology is at a bit of a tipping point. And again, that's why I just think this space is so exciting to be part of, because what was true yesterday isn't true today, and what will be true tomorrow will be a whole different thing. So watch this space. And then finally, plastics. So plastics are another very fossil fuel dependent industry. Today, you can have biopolymers that generally produced from wheat or castor beans. So my university dissertation was actually looking at making PLA, which is a polymer, which is a forerunner of plastic, from wheat. And that was not much more than 10 years ago. And at that time, it wasn't a particularly commercially available technology. The first plants were just being built, and today you can buy it at commercial scale. I work with a company called Airway Medical that are looking at mass producing a device for clearing lungs from plastic that they can buy that's made from castor beans. It's commercially available. But same with e-fuels, there's a potential that the amount it can scale will be limited because of the other uses for food crops. So again, this is where I do see carbon capture technologies becoming massively transformative in that industry. So just as we think about traditional refineries where you would take crude oil in and split that up into things like naphtha, which is a feedstock for plastics, diesel, which is a fuel, I can see a world where we're taking CO2 in and almost reverse engineering it into useful fuels and feedstocks for plastics. And again, the beauty of these are drop-in replacements, which means we don't have to go and knock down existing fuel terminal facilities or existing plastic production plants. We'll just have drop-in replacement feedstocks and fuels.